Hello everyone, in this video I'm going to show you how to run Factorial ANOVA using Rstudio. So what do we need to have to run Factorial ANOVA in Rstudio? Firstly, you need to have installed your Rstudio along with your R software. Next is you need to import your data file into Rstudio. So once you have your Rstudio operating, you need to import the data file into Rstudio, and in the data file you have to make sure that you have an independent variable and also dependent variable. In your independent variable, you should have two independent variables which are both categoricals. Both the independent variable has to be categorical, and they need to have 2 or 3 groups or 3 levels above. Okay, and then you have to have another variable called dependent, the outcome variable, which should be in the continuous level of measurement. So once you have your Rstudio, you have imported your data into R. Next is you have to select appropriate package to run the analysis. So in this case we are still using the site package. And then the fourth one is you have to start writing the R script, okay, in order for the Rstudio to run the analysis. So what are the important things that you need to write or instruct the Rstudio? Firstly, you need to set the working directory. Second, you have to load the library, meaning you have to call in the library. Third is import the data file into Rstudio. So in this case, your data file is in the CSV format. Next is once you have your data in, you need to start testing for the assumptions. So what are the assumptions for Factorial ANOVA, or what do we mean by assumptions? Okay, when you're doing manually, we did not check for assumptions because it will be more calculation. So we assume our data is normal and it is appropriate to run Factorial ANOVA. But when you are doing with an assistant or help with the software, you should be testing whether your data is appropriate or not. So you need to test for some of the assumptions that we make about our data. Is it true? Our assumptions true about the data? So what are they? We have to test for normality of the data. Is the data normally distributed? Is especially the outcome variable, the outcome data. Okay, normality is for continuous data. Is it normally distributed? So for categorical, we do not run normality test for categorical variable. We only run normality test for continuous variable. Next is test for independence, meaning whether our responses, every response that we get should be independent of one another. It should not be influenced by another person's response. Okay, meaning that when people answer the question, they answer it by themselves, was not influenced by another participant in the group. We cannot test independence at this point. We assume when we are collecting the information, collecting the data, we assume that nobody has influenced the respondent in their responses. The third one is homogeneity of variance. Remember, we are using variability or the variance as a key to analyze. So before we make comparison, we want to make sure are the groups equivalent in terms of the variability. Okay, we need to check that. So that is what we are doing through homogeneity of variance. So is it homogeneous? Is the variance between the groups similar? Okay, homogeneous meaning similar or different. Okay, if it is similar, then there is a we say that the equal variance has been assumed, and if not, we say that unequal variance are being assumed between the groups. Okay, and then once we have tested and reported all the assumptions, we go direct to the analysis. Okay, for illustration purposes, okay, to show how to run it, we have used a data Okay, in that data, we were actually interested to examine how factor A, which is the day, and factor B, the type of program, has any influence on the number of inquiries received by a company. Okay, so there is three variables. One is factor A, that is the day. Factor B is the type, which has three levels: business, sports, and news. And then the outcome variable is the number of inquiries received. So what is actually the scenario here is a company is airing, putting advertisements 2 days in a week during a business, sports, and news program. So on Mondays during the sports, news, and also during the business program, they put the particular advertisement, and then they do that again on the Friday. So this company is interested to know after which commercial ads do they get more inquiries about the product. So is it like on is there a difference on the number of inquiries they get during the day, whether it's on a Monday or a Friday, or during the program that we conducted? Okay, whether it is during the business program or during the news, or is it during the spots. So they want to know which one is actually influencing the number of frequencies. So we are going to run a factorial ANOVA. So we would like to examine the two factors together on the number of inquiries received. So what the script means, what is the factorial ANOVA script means? Okay, so as I said, firstly is we need to set the working directory, meaning you have to specify where is your data located. Okay, location of the folder. Next is you need to tell, remember, load the library, activate the package that you would like to use, because this package contains of what? Contains of functions that you would like to use to run the analysis. So in this case, I'm using stats and also site package. That is, you have to import the data file into Rstudio, meaning that you have to call in the data from the directory that you set. So in my case, I have set my directory at the E folder. Okay, my pen drive, called the folder name was demo, and then another folder ftest. Okay, so I've kept my data there. So anything that later on that I want to save will go directly to that particular file or folder. So now once I have imported, I would like to test the assumptions. So first one is the test for normality. Okay, so what I'm going to do here is I'm going to test the outcome variable, which is the inquiries. Okay, number of inquiries by the factors. How many factors I have? 2, day and type. So that's why I have here describe by. So what the function is telling is, please explain the normality for, or please explain the inquiry from the file, from the data called data. Okay, data. I'm labeling my data file as data. Okay, and then there is a variable called inquiry. Okay, so please examine or describe it by the day. Okay, so the next comma, date by day. So here it's going to explain by day. Then followed by the next one is describe my inquiry data by the type. Okay, so distribution of the dependent variable by day and type. Next, as I said, is test of independence. We assume it is being met. Okay, because there is no specific statistical test for it. Now the third assumption is homogeneity of variance. So we are testing by day, by the first factor. What is our first factor? Day, Monday and Friday. So we would like to see whether the variance that we find in inquiry, is it similar across Monday and Friday. Okay, then we are doing 4 types of program. So we would like to see the equality of variance. Is the variance equivalent for equivalent between the three types of program. But what variance? Variance in the outcome variable, which is number of inquiries. So the variability in the number of inquiries, is it similar across sports, news and business program, or is it different? So that is what we would like to test here. And then on the fifth step is run the analysis. So what I have here is two-way. Okay, so this is a label. Okay, you can put it as a two-way. Okay, there is a no dot. Okay, whatever that you put before this arrow, it is for your own references. It's just like you are labeling, you have more control. But after that, what we have is, after the arrow is analysis of variance, AOV. Okay, AOV means analysis of variance. So, and then parenthesis inquiry as dot factor type, and then this is a asterisk mark as factor day. So what we are trying to say is, okay, examine the effect of the type factor and the day factor on the inquiry. So where do I get all this information about day, type and inquiry? Is from my data set. So the data, you get it from my data. Okay, so and then you close the parenthesis. So once it runs the function, when you type summary two-way, you will get the results. So how do you interpret the results? So for the first set, okay, setting the working directory. So this one you will be able to see that the data will be the file will be activated or being like identified as a location. Then when you load the libraries, okay, it will also appear on the history tab. Okay, on the history tab on the right hand side on the top, you may able to see. Okay, next is you are able to import the data. So what when you import it, you can see the name appearing. Okay, the name, a data or any name that you put in will appear on the environment tab. Now when you test for assumptions, we looked at the descriptive statistics for inquiry data by day. So by day meaning, you see there is two groups, for Friday and for Monday. So they examine, okay, so for variable, how many observations do they have? Okay, so for Friday they have 24, for Monday they have 24. So what is the mean, what is the standard deviation, what is the median, blah blah blah. So you have all this information, descriptive information for descriptive information of the inquiries for group Friday and also for group Monday. So where do you test for normality? What is the information that you need for normality? But before that, that was for day. Okay, and then we did that again for the type, because type is the next factor. How many groups do you have? How many levels do you have under type? You have 3: business, news and sport. So same thing. So it has 16 observation for each category. Okay, and then it reports the mean, it reports the standard deviation, blah blah blah. Okay, so what it does is it gives you a descriptive summary or descriptive information by the level in that particular factor. So the first factor just now was day. So how many levels or groups do we have? Monday and Friday. So that's why it splits and give you descriptives by the group. For the second one is you have 3 groups or 3 levels within the type for business, news and sports. So it gives you the descriptive statistics for each of the group. So where do you find the normality? Okay, so look for the skew variable, the skewness variable. Okay, so what is the value for the skewness? Okay, so it has a criteria. So the skewness value should be plus minus within the range of 2. So it can be anywhere from -2 and 2. It cannot be less than -2, or you cannot be greater than +2. It has to be within that range. Okay, so if it is within that range, then the normality has been met. So in this case, all of them are below that or within the range. Okay, negative 0.25, 0.34, 0.07, 0.46 and 0.34 is all within the negative 2 to 2 range. So the normality has been met. So what we're testing for? Homogeneity of variance. So we would like to see if the variances within that particular level or groups for each factor is same or different. So we test for the equality of variance for the factor day. Okay, for the factor A day. So what we do is they are looking at the two variances. We compare the two variances, and what is it that we need to look for? We have to look for the p-value. Okay, so this p-value indicates that whether it is greater than 0.05 or less than 0.05. So if it is greater than 0.05, meaning there is no significant difference between the two variances. Okay, between the two variances. So meaning the variances that exist, the variability between the group for the day Monday and for Friday is the same. So the variance for the inquiry variable, which is the outcome variable, is the same for Monday and Friday. So when you test again for the factor B, which is the type. So in type we have 3 groups. Okay. So in these 3 groups, what we are doing is we are trying to estimate the equality of variance or homogeneity of variance. If you notice, the homogeneity of variance tests are slightly different. Here we say var.test. Okay, here on the second one we say Levene's test. Okay, so why there is a difference when you are examining homogeneity of variance? Okay, that is, you need to understand when we are using var.test is when you have only 2 variances to compare. If you have more than 2 variances to compare, then you have to use Levene test. Okay, Levene's test. So if you notice, for day I have only 2 variances for Monday and Friday, but for type I have for 3 different programs. I have it for business, news and sports. So you have to be careful. So how do you interpret the results from the Factorial ANOVA? So a Factorial ANOVA is you run 2-way, okay, and then it is similar to how you calculate Factorial ANOVA or 1-way ANOVA by hand. So remember the table of summary of ANOVA that you have to produce. Okay, what does it contain of? What or consist of? The source of variation. So the first column is actually the source of variation. The variation caused by factor A, which is the type. Variation by factor B, which is the day. Factor A is actually the day, factor B is the type. Okay, and then the interaction between the 2 factors. Okay, and then you have the degrees of freedom, sum of squares, mean of sum of squares, the F value, and also the probability value. Okay, this is what is different from calculating manually. So what do you do manually? You stop at F value. So what do you do next? You find the F critical from the table, and then you compare this F value to the F critical, and then you conclude if there is any significant difference for that particular factor and also for the interaction. But what the software does for you is, instead of calculating the F critical, it calculates the probability value. The probability value that is associated with this F value. Okay, so what we do is we examine the p-value and then compare it with the predetermined alpha value. Okay, so our alpha values we usually set at 0.05 or 0.01. Okay, so since this probability value, okay, since the interaction's probability value, this is the interaction, is less than 0.05, it shows that the interaction is significant. So when it's significant, remember interaction is like you have 3 groups of programs and then you have 2 days. So it's like almost like 2 by 3 factor, okay, 2 by 3 combinations. And then so you need to examine exactly where the difference actually exists. So you need to do the follow-up analysis. So here you need to run a simple main effect analysis. If the interaction is not significant, okay, if this p-value here is greater than 0.05, then you have to examine the main effects. So you have to check whether the type is significant or not, if the day is significant or not. So if they are significant, then you have to examine where the difference actually exists. So now what we need to do is we have to run a follow-up analysis. So how do you run a follow-up analysis? So a post-talk analysis. So same like in one-way ANOVA, now you have to run a post-talk analysis. So post-talk analysis is very simple. So what you need to do is you select Tukey's HSD as a post-talk analysis function, and then the two-way. The two-way is actually from the previous slide. When you're running a one-way two factorial ANOVA, we have given a name for the analysis. So we want to run a post-talk analysis for that analysis, for that particular two-way ANOVA analysis. And then with that, you should be able to run the post-talk. So this post-talk analysis, what it does is, okay, when you are doing interaction, okay, when you are looking for simple main effect, if you remember the follow-up analysis chart, you need to split the file, okay, because you want to know at factor A where is the difference, for factor B where is the difference. So you have to split them up and then make the comparisons. Okay, so in here what happens is you don't have to do the splitting. You don't have to worry about how to split the file. So the software itself will do the splitting for you and run the analysis for you. So it's just by just writing this function and running it, you are able to get all the splits and all the analysis. So what you can do is you can compare between factor, okay, between factor A. So the day you can compare between day Monday and Tuesday, Monday and Friday, and then you can also compare between the groups, okay, between types of programs, business, sports, and news, and also compare between the combination of factor A and B. So it actually gives you a very comprehensive and detailed follow-up analysis. So what are the possible comparisons? Okay, remember when you have a significant interaction, you need to run simple main effect. So if your interaction is significant, you have to follow the path of simple main effect. Okay, because they are connected. So meaning that some people, some program on Monday and the combination of it has different from Friday's programs. Okay, so there is like a mix. So you want to split them up and then examine where do this difference truly exists. Okay, so it is, if you notice, there are 2 days, Monday and Friday. The column is Monday and Friday, and then the type is you have 3. So basically you have Monday business, Monday news, Monday sports. You have Friday business, Friday news, and Friday sports. So basically you have like 3 by 2. Okay, so you have about like 6 possible characteristics here. And then what we are doing is comparing within each level of factor A. Remember, we would like to split them up. So you want to split by factor A or factor B. So in this case, the first one is split by factor A. So my factor A is the day, Monday and Friday. So within Monday, what I'm doing is I'm comparing between business and news, news and sports, business and sports. So I have all my Monday data, Monday inquiries, and within there I'm comparing the number of inquiries before, during business program and the news program, business and sports, news and sports. So that is what here the Monday means. Okay, and then the Friday. So on Friday, what happens is I am comparing between business number of inquiries and the number of inquiries after the news. So and then the number of inquiries after news versus the sports, and then the number of inquiries after the business versus the number of inquiries after sports. So what we are doing here is we are splitting by factor A. So for factor A is the day. So day you have two levels. So the first level is level is Monday. So from Monday, what I'm doing is in Monday I have sports, business and news. So I'm comparing the number of inquiries between the three groups. Okay, and then same thing that I do with Friday. Okay, that is, you are splitting the factor by the column by factor A, but you can also split it by business, by news, by sports. So that is comparing within each level of factor B. Okay, so within within each level of factor B. So what are the levels in factor B? Factor B is the type of program. So how many levels we have? We have 3: business, news and sports. So for business, you can compare between Monday's business and Friday's business. Okay, news, you can compare between Monday news and Friday news. You can also compare the number of inquiries, okay, on after Monday sports and Friday sports. So what we are doing here is we are just comparing between two groups here. Okay, two groups for each level of factor B. So for business, you compare between Monday and Friday. For news, you compare between Monday and Friday. For sports, you compare between Monday and Friday. Okay, so altogether you'll have like 3 different comparison. Okay, so that is by every factor. Okay, so you are being very specific, just by factor A, factor B, and then you make the comparison. But what this the software also gives you is the cross between the factors. Okay, so you can also compare Monday business, the number of inquiries after Monday business program and Friday news program. Okay, because remember, Monday business and Friday business, you already compare it. Okay, under the business program, under the business, you already compare between Monday and Friday. But you can also compare between Monday business and Friday news. That is what you notice here, the first one. And then the second one is you can compare between Monday news and Friday business. So FB. And you can compare Monday news and Friday sports. Okay, and then you can compare Monday sports with Friday business. And then you can compare Monday sports with Friday news. So altogether you will be able to get 15 different comparisons. Okay, 15 different possible comparisons that you are able to identify, or you can play with, or to make comparisons with. So this is how the result will show up on the from the Rstudio. Okay, so once you run the Posttalk analysis, okay, it will tell you what was the equation that has been used to fit, and then it gives you three different results. Okay, the first one as factor type. This is the main effect for factor B. Remember, Rstudio actually gives you whether it is the interaction is significant or not. It gives you all the comparisons, all the possible comparisons. Okay, but you need to be specific on examining what you want. So what it's presenting here is the main effect for factor B. Factor B is the type. So it compares between news and business, sports and business, sports and news. It doesn't care about is it on Monday or it is on Friday. It is doing it as a whole. Okay, it's just between the factor. It's just like running a one-way ANOVA, and then you are doing a Posttalk. Okay, now for as factor A, the day, okay, it also examine the effect. So factor A only has two levels, Monday and Friday. So that is what being examined here. Okay, these main effects, okay, these main effects of the factor, you do not have to interpret it if your interaction is significant. So if your interaction is significant, you have to go to the last box here, which examines simple main effect. Okay, so where it is split by factor A and factor B. Okay, let's look at the first one. It is news Friday minus business Friday. So what is this thing is trying to say? It is comparing news and business on Friday. Okay, so on Friday, it is on the Friday level. Okay, Friday, it's comparing the mean of inquiries between the news and the inquiries that they get after business. So for the second one is sports on Friday and business on Friday. So on the same Friday, you are comparing the number of inquiries received after sports and after business program. The third one is business Monday, business Friday. So what are we examining here? It is on business, okay, on the level of business, you are comparing between Monday and Friday. Okay, so you are comparing business inquiries. So all are business inquiries, but between Monday and Friday. The fourth one is news Monday, business Friday. So what is trying to examine here is the number of inquiries that one get on Monday after the news, and and the number of inquiries that you get on Friday after the business program. So that is what it is being illustrated here. Okay, so you look at about possibly 15 comparisons, and then you have to look at the p adjusted or the p value adjusted. Why adjusted? Because there are a lot of tests that we are running, so it is already being corrected for type 1 error. Okay, so how do you, okay, so as I said, this if you have a significant interaction, then you have to focus on this table. So in this table is actually Monday sports versus Friday business, Monday news versus Friday news, Monday sports versus Friday news, Monday sports versus Friday sports, Monday sports versus Monday business are the pairs that are having different in number of inquiries, so which is flagged as significant. How do we know this is being flagged as significant? Check at the p adjusted value. So if the values are less than 0.05, then we can say that these pairwise comparison are found to have significant differences. So here for Monday sports versus Friday business, okay, which is sports on Monday, business on Friday, the p-value is 0.03, which is less than 0.05. So we say there is a significant difference. So what you need to do is, firstly you need to identify in your ANOVA results your interaction is significant or not. If it is significant, then you have to go direct to this table, okay, as factor type as factor day. Okay, so maybe in your case or when you're running it, there might be different variable names. Okay, so you have to focus here. But in case your interaction variable is not significant, then you will go to this main effects. Okay, so you analyze or examine this factor A, which is day. Okay, so you look at the comparison at the day and also the main effect for factor B, which is the type. Okay, so you report this too. If it is significant, you focus on the third table. If the interaction is not significant, then you focus on the first two. Okay, the main effect of the variables. Okay, I hope it was